Hi, I hope you're enjoying Spinnaker Summit so far, and thanks for joining the session of To Go or Not to Go, 4 error metrics you need for confident release validation. I'm one of your hosts, Eric Mizell. I'm the VP of Solution Engineering at Overops, and I'm joined by my good friend Lee. Lee, you want to introduce yourself?
Sure. Thanks, Eric. My name's Lee Faus, and I'm a field CTO at Armory.
Awesome. Well, thanks for joining today. So today we're going to talk a little bit about Canary deploys. The world is moving faster, and we're moving to this faster deploys and deploying through Canary, and how you deploy today and how decision support is done, and sort of where some of those gaps are, and how we can bring some new error metrics into our Canary deploys to make them better, more sound. And we'll take a look at a hands-on example at the end. So let's kind of paint this picture. Speed and quality is always a challenge, right? We want to move faster. This end goal of how do we increase velocity through continuous delivery? How do I deploy early and often, faster, with higher quality, right? That's always a challenge because the faster we move, we tend to lose quality. And then how do we reduce our risk? So you can envision as I deploy code, and if I deploy something that causes an outage, features that don't work that used to work, now my risk goes up. We lose customers, we lose brand recognition. So this goal of automating this process, getting these things done faster, repeatable, with confidence, that's the goal, right? That's what we're all after. So we know from facts, we've done studies, there's case studies out there, that there's trends in software quality, right? Most developers spend 60% of their time fixing and debugging errors, right? So these are our best guys spending time fixing these issues when they should be working on new features. We know that a lot of companies prioritize quality over speed. And so it's good that we prioritize it, but then what's the trade-off? We don't get features out fast enough. So there's these trade-offs and challenges that we all go through, right? So how do we improve on that? So I think the first thing is really understanding decision support when I do a Canary deploy. And for that, Lee is going to take us through it.
Great. Thanks, Eric. So when we talk to a lot of our customers, they struggle with this model of non-production and production type deployments. And there's a bridge that goes between the two of those, which is managed usually through some manual process, change review boards, security review boards. And a lot of the data that's collected around that is done manually. So a release manager or an SRE or somebody will go to the app dev teams and they will talk to the QA teams and are there any blockers? Are there any Sev ones? What tickets actually made it into this particular sprint for this particular release? And when they do that, they're gathering a whole bunch of data ad hoc. And when we go into these meetings, a lot of the data that we're looking at is very subjective. And what we want to do is we want to get away from the subjective go, no goes. And we want to be able to feed our continuous delivery solutions with as much data as possible. And that data is going to come from things like our APM vendors, where we can be getting our metrics, from our logging solutions, where we can be looking at errors that show up in the logs, and then our policies. So using open source products like OPA and being able to look at security policies and best practices for an organization, funneling all of those in as a set of data and being able to come up with one concrete source of truth that lets us know if it's okay for us to be able to move a particular application from non-production to production. So inside of Spinnaker, if you haven't started using the Kayenta service, which will enable Canary analysis, I highly advise that you start thinking about how you could use this in your environment. Now, there's 3 best practices for when we go off and we do Canary analysis. And this really depends on the amount of traffic that's going to end up being generated through your application as it sits in a soak or a staging area as we try to collect the data. Now, if you aren't able to generate a ton of data, a lot of our customers will deploy a one-to-one mapping between our old release and our new release. and we'll send a bunch of traffic to both of those and then scrape the data from the APM vendor that allows us to be able to compare the performance of those two applications simultaneously. If you have an application that is generating a lot of traffic, like a born in the cloud type solution, like Airbnb or GitHub, or Facebook, you're able to go and do these things in the real world. And we can do something called traffic shadowing. So all we have to do is deploy our experiment and we can collect the data live. If either one of those environments doesn't work for you, we can also go back and support a model where we can collect a soak where it can be some amount of data that you're monitoring from prime utilization during the day from 11 a.m. to 3 p.m. And then we can use that data as a point in time reference and then always compare that against an experiment that we can go ahead and do our decision support from that information. Now, once we have a Kayenta stage enabled, there's a number of different ways of configuring it inside of the stage details. Now, a majority of our customers really are looking for that real-time, instantaneous feedback on if this particular non-production deployment is ready for a release. When we go ahead and configure it, there's going to be a Canary configuration file that you're going to define that will allow us to be able to look at things like CPU, memory, latency, things like that that are available from your APM vendor. Other things that you're going to want to do is you're going to look at that data at specific intervals in time. If you're doing a soak for 24 hours, you're not going to want to be scraping the data every 5 seconds. You'll probably scrape that data maybe every 5 minutes. Might want to do a delay if you've got an application that has high level of caching. So you want to make sure you're building the cache up before you start doing your analysis. And then we can go and do look backs. So do we want to see this as a growing trend or do we see this as linear trends? And then what we need to do is we need to be able to define what our baseline is and what our experiment is. When you execute your pipeline definition, you're going to see inside of here all of the different intervals that you had. So if we say that we're going to run this for an hour and we're collecting data every 10 minutes, you're going to see 6 intervals. And during each one of those intervals, we're going to do a calculation. And then there is an aggregate that happens across, which is going to look at the standard deviation between all of the different runs to allow us to determine an overall evaluation of that canary that you can then see to be able to do either a manual judgment or an automatic promotion. So when we look at the decision criteria, a lot of people see Kayenta as being able to look at CPU, memory, performance around latency. But one of the things that we get asked about a lot is, what about just generic errors? And errors are easy if you have a high quality app dev team, and that app dev team is using best practices around creating exceptions, making sure that when there is an exception, that they're not just throwing a generic exception, that they're actually throwing you a JDBC connection exception, things that will allow you to drill down into those errors so our SREs and our operations teams aren't doing things like trying to find a needle in a haystack. Now, today's metrics don't paint the full picture, and that's where I want to throw it over to Eric to be able to drive in more about what OverOps is doing to be able to solve some of those pain points.
Perfect. So to your point, Lee, the metrics come from multiple places, right? We have APM, log data, infrastructure. Those are all critical and important, but they're not necessarily always focused on the application and the run, especially the running application. As you mentioned, errors come in all shapes and sizes. Some of them aren't even logged. So if you're relying on reading from a log and it's not in the log, you don't know, right? And so you have a lot of hidden things going on, and then you don't necessarily get a way of classifying those errors or knowing if they're new or critical. So you sort of are missing part of those critical components to make a better decision. Should I roll forward? Should I roll back? Can I do a patch? Those types of decisions are harder to make. So we want to be able to incorporate deeper error metrics, right, into our Canary deploys. So there are 4 key metrics we like to look at. The first one is new errors. And this to me is one of the hardest things. How do I detect a new error that I've never seen before? It's super hard, right? Looking at a log, it's not an easy decision to make because logs, as Lee mentioned, are relying on best practices and a developer to do everything perfectly. And it's not always the case, which is okay. But in dynamic code analysis, we can do this. We can fingerprint your code. We know if it's new, and we can help you make better decisions based off of an error that never existed before. The next one would be a critical error. And critical errors come in, again, different flavors. It can be a null pointer, an index out of bounds. It could be your custom exception. It also can be a silent killer, which would be like a swallowed exception, or even some uncaught exceptions, things that are hidden from us. They're not in logs. They're not showing up in our APM, and we don't even know. And those ones have caused a lot of people pain, including myself. Error metric number 3, resurfaced. One of my favorites. We fixed this thing 2 months ago, and it comes back. No one knows why. And it tends to be I had an issue with merging code or the like. And being able to know it's resurfaced helps me to solve the issue faster, and also helps me classify, is this an important error? The last one is a unique error total. So we see this a lot with our customers where they just do a count. So I query an APM or I query a logging infrastructure and says, hey, I have X number of errors. The biggest challenge there is the deduplication of those, right? So if I'm relying on basic deduplication, it doesn't always tell the whole story. And so dynamic code analysis is able to do this at the bytecode level. So now we know that this error is the same error, so it doesn't give me false increases or false decreases. So I can get a very clean, unique error total count for my decision tree. So let's take a look at a hands-on example. Lee, you want to kick us off?
Sure. So when we were looking at the dropdown in our stage for being able to implement a canary analysis, this particular screen is where we actually configure our metric that we want to gather. So inside of here, you're going to create a group. So there would be a setting inside of this Canary config that you would create a new metric configuration. And then here we're grouping things together by errors. We have a name that we want to be able to specify across this. And because this is errors, most likely we're not looking for an increase or a decrease to throw an error or warning. What we're really looking for is we're looking for an increase in the errors over time. And then we have our metric that we're looking at here from overops, where we could be looking at something like total errors new that Eric just described. The great thing about this is when we were executing the pipeline and we went into the Canary, what you can do is on any one of those different intervals, we can go in and look at the Canary report. Now, this particular Canary report is, again, as we had our Canary configuration, this is real time. And one of the things that Eric and I have talked about a lot over the last couple of months is there's sort of 2 models where these products overlap. So one of the things that we have is this release validation using decision support. And as we think about doing that, that is really where Spinnaker comes in and sort of saves the day for a lot of those release managers. And when we look at this data, we can see exactly where things could be going wrong or where things are going right. And hopefully the goal is here that we get everything as a pass. Now, there's a part where overops can continue to do verification of your application in production. And as it's monitoring that application in production, there's going to be things we can only simulate so much data in a non-production environment. Even doing traffic shadowing, we're only sending a slice of the data that's coming in, and we're never sending responses back to the users. So we're not seeing things, let's say if I'm monitoring a WebSocket or if I'm monitoring gRPC type traffic where I'm doing synchronous communication. So because of that, we need a way to be able to monitor things post-production. So now with overops, if it continues to use the exact same metrics that we see here on the screen, it can send a webhook back into that release pipeline that we just defined. If it sees anything that goes out of bounds, we can come back and do a rollback of an application that originally was seen during Canary as successful. So now you have this model that can be super powerful where you're not just going ahead and throwing it over the wall to the release manager, letting it go into production. You have this safety net that's running in the background. And then from here, inside this Canary analysis, if we are doing this, what you can do is you can click on one of the links and that link can send you into overops. And I'm going to send it back over to Eric to go ahead and describe what those different metrics look like.
Perfect. So as Lee mentioned, you in this situation, you might click on unique error total and it would take you to the overop screen showing you those errors, right? And what's interesting is you can see how many times, at what rate that error is happening, where it's coming from, is it happening at this peak time? So once I capture this information, then the next thing is I want to know, is it critical, right? So I've got this information. Now with overops, you can drill into root cause. And when I mention root cause, it's not a stack trace. It is source code, variable state. So all the data at the time of the event for the entire stack trace with all the commit data as well. So what makes this interesting is now you have the tools in your toolkit that tells me, hey, this is a critical error. And it looks like Julia made this change on April 1st, and I can actually click that commit and go right to the Git repo and see the delta in the code and the commit details. So now you know, hey, this is critical. I need to roll back or do a patch, or I'm okay, I can survive, but I need to get this fixed soon. So having deep root cause along with in an automated fashion gives SREs and developers the kind of data they need to make decisions in real time, as Lee mentioned. So I hope you guys found this useful. Any final thoughts, Lee?
Yeah, one of the things that Eric was just describing, I think, is something we don't think about a lot. A lot of times we think about as an app dev, we're constantly thinking about moving things forward. And we move things forward based on a ticket in Jira. And it's either done or it's not done. And if QA writes a regression test against something and that regression test comes back as everything looks good, we don't have the other data that surrounds that test that allows us. A lot of times we see applications that need to go to a quote unquote perf environment. Being able to wrap performance monitoring and error monitoring and policy management, taking all of those things into that decision support allows the app devs to now think about everything in a sprint around what actually makes good code at the same time as being able to implement the velocity that we want from our app devs at the onset. So Eric, back to you.
Perfect. And so yeah, my final thoughts. If you remember where we started, how do we get to this, beautiful world of moving fast, lower risk, continuous deployment? This is it, right? You bring all these pieces together with full automation tools and decision support brought from you by multiple tools, right? And you get the best data together and you can make a proper decision and you get to this automated world where it just happens. I think that's the magic. So again, thanks Lee for joining. I hope you guys found this session useful. Stop by the Armory booth if you get a chance. And again, appreciate the time. Thanks so much.